Welcome back to part 7 of chapter 5. Okay, so we were looking at the answer for this example 3. Alright, so okay, we have looked at the answer. Now let's move on to the next part. Now here we are going to look at the relationship, important relationship between these elements, these 4 elements. Okay, so we look at the relationship between 2 of these 4 elements, and we see how one relates to the other. So for a given interest rate, the longer the time period, the lower the present value. So this is an important relationship. It says greater or longer the time period, greater the n, lower the present value. Given that the interest rate, given the interest rate is constant. Not only the interest rate, the future value is also constant. Alright, so let's look at an example. What is the present value of 500? This is future value to be received in 5 years. So this is future value, n is 5 years. Okay, and then the discount rate is 10%. That's the first example. The second example is the future value is 500. Now the n is 10 years, not 5 years. We change 5 to 10. The discount rate remains the same. So when you compare the two, again, there are 2 elements that are constant, which is the future value, which is 500, and the discount rate or the interest rate, which is 10%. But what we change is this 5 years, and we change first it's 5 years, then the second one is 10 years. So we change the n, and we want to see what happens to the present value. You look at present value. It's 5 years. 500 divided by 1.1 raised to the power of 5. 1 plus 10% raised to the power of 5. You get $310.46. But if it's the same, okay, with 10 years, you discount over 10 years, the value is smaller. Okay, it's lower. So longer the time period when these two, 500, the future value and the interest rate is constant, higher the n, okay, lower the present value. Is that okay? Lower the n, higher the present value. So it is negatively related. So they are not positively related, but they are negatively related. Longer the time period, lower the present value. With the interest rate and future value unchanged or fixed. Alright. Now we can also conclude for the future value, not only for present value. So this here refers to the future value. Longer the time period, higher the future value, with interest and present value unchanged. We have not seen this relationship here. It does not describe it here, but you can try it on your own. Okay, in this case we hold present value and the interest fixed. We change the time period. Longer the time period, you will find that the future value will become higher. That's the relationship. Okay, so these 2 relationships are important to understand. Alright, now we look at the second relationship. For a given time period, higher the interest rate, the lower the present value, or smaller the present value. So again, this is a negative relationship. Now we look at the same or similar problem. The present value of $500. This is the future value. The future value is fixed. Received in 5 years if the interest rate is 10% and 15%. So note that here the future value is fixed and the term is fixed. Okay, previously the term was varied, was changed, but here the term is also fixed. What we change here would be the interest rate. From 10% we raise this to 15%, and we want to see what happens to the present value. So here the present value, this we have computed earlier, 500 divided by 1 plus 10% raised to the power of 5, you get $310.46. But if you raise this 10% to 15%, these two are fixed. 500 is fixed. The term 5 years is fixed, same. But here the difference is 10%, you raise this to 15%. What happens? The present value is lower. Yeah? So therefore we can say higher the interest rate, lower the present value. Yeah? Because you are discounting it at a higher rate. Yeah? When you discount at a higher rate, you are removing more interest from the principal. Therefore the present value will become smaller. Yeah? Higher the interest rate, lower the present value, with the time period and future value fixed or unchanged. What about future value? Yeah? The higher the interest rate, higher the future value. Yeah? Time period and present value unchanged. Okay, when you look at the relationship between interest rate and future value. Here the interest rate, the relationship is between the interest rate and the present value. Yeah? So always with future value, okay, interest or the time period is positively related. But for present value, interest rate and the time period is negatively related to the present value. Okay, discounting, okay, or compounding. Now this is a very important statement. Let me just bring it down so that we can see the full statement. Right, discounting at a higher rate or over a longer period reduces the present value. Yeah? Other things being equal. Ceteris paribus means other things being equal. Yeah? Or other factors remaining constant. But if you're compounding at a higher rate or over a longer period, that increases the future value. Right? Other things being equal. Yeah? So this is an important statement to understand. Don't memorize the statement. So try and understand this. You can actually apply this and try this out. You change the interest rate and then you change the time period and see what happens to the present value and the future value. You can have your own examples, and you can have a feel for that relationship. Okay, let's move on. Okay, so with that we finish. We come to the end of this second key part of this chapter, which is the present value. So we do a quick review by going through this quick quiz of what we have learned in this second part. Okay, so what is the relationship between present value and future value? What is the relationship? This is positive relationship. Higher the present value, higher the future value. Note that this relationship is not about present value and interest or the number of periods or time period. This relationship is between present value and future value. Higher the present value, higher would be your future value. Remember the formula? FV is equals to PV multiplied by 1 plus R raised to the power of n. Therefore, if R and n is held constant, higher the present value, higher would be your future value. And vice versa. Lower the present value, lower would be your future value. And this applies also to future value. Higher the future value, higher would be your present value. Okay, and vice versa. Okay, now let's move on to the second question. Suppose you need 15,000 in 3 years. If you can earn 6% annually, how much do you need to invest today? This is a typical present value problem. Let's look at the three elements that are known in this particular problem. The first one is 15,000. This is future value because this is 3 years from now. This is not now. Okay, therefore it's 15,000. Okay, that you need. Okay, the term is 3 years, n is 3 years. Okay, and interest is 6% annual. Okay, 6% annual interest. This is R. So there are three elements known. So the fourth element, which is not known, is the amount that you need to invest today. That is the present value. Therefore, you can use the formula for present value. 15,000, the future value divided by 1 plus 6%, the interest rate, raised to the power of 3. So you're discounting 15,000 at 6% over 3 years. You get 12,594.29. Now let's move to this question. In this question, you don't need to compute. Okay, you just need to consider if you could invest the money at 8%. Know this, the same money, this is what you need, okay? But if you can invest whatever money that you invest at 8% rather than 6%, okay, would you have to invest more or less? Yeah. And then the second question is how much. So first, without computing, try and consider this. If you can earn, whatever investment that you have, the money that you have, if you can earn 8% interest per year, okay, and you want 15,000 at the end of 3 years, would you have to invest more or less than compared to if you can earn 6%? Yeah, because the future value is fixed. Okay, this is fixed. The term is fixed. Okay, the interest rate is higher. Note that 6% is lower, 8% is higher than 6%. Therefore, the present value, how much you need to invest now, should be lower than this value. It won't be as high as this. You can invest somewhat lower amount. Okay, less, as you can earn higher interest on a lower principal to attain a fixed future value over a fixed period. So again, here in this statement, you find the 4 elements. The relationship is less, meaning you need less, okay, lower principal here, lower present value, because you can earn higher interest. 8% is higher than 6%. Okay, given that you need fixed future value, which is 15,000, and you need over a fixed period, which is 3 years. Okay, that is the answer. Okay, so the answer here, actually, if you compute how much, the question was how much, so you can just replace this 15,000 divided by 1 plus 6%, you replace with 8%, the rest would be the same. You find that this is lower. You discount at a higher interest rate, you get a lower value, lower present value. That means here you need to deposit only, invest only this much, because even though this is a lower amount, for the lower amount you earn a higher interest rate. So over the same period, 3 years, you get the same amount. Okay, 15,000. So that's the idea behind this problem. Alright, let's move on to the next part. Okay, this is a review. Okay, we will skip that. Now we come to the third key part of this chapter, which is about the discount rate. Not necessarily only discount rate. We can call this interest rate. Okay, often we will want to know what the implied interest rate is on an investment. So here the unknown element is the interest rate. Remember the 4 elements in the basic time value of money problem, a simple time value of money problem. There will be 4 elements. 3 will be known, and 1 will be unknown. So in this case, if the interest rate is not known, okay, then you try and solve for the interest rate or the discount rate. So the other 3 elements must be known. So we can rearrange the basic present value or future value equation and solve for R. This is the basic time value of money formula, future value formula. Okay, now you rearrange based on this R. So what you do, you bring this over to the side, future value divided by present value. Then you raise both sides to the power of 1 over t, because you want to bring this to the power of 1, right? Therefore, you multiply or you raise both sides of the equation with the power of 1 over t. It is the inverse of t, or the reciprocal of t. So you get future value divided by present value, all this raised to the power of 1 over t, the reciprocal of t. Then you minus 1, because here is 1 plus r, right? So you minus 1 from both sides of the equation. So you get r here, okay, and you get minus 1 here. So this is the formula. Okay, so you can write it this way. Okay, r is equals to future value at the end of period n divided by present value now 0. Okay, all this raised to the power of 1 over n, or raised to the power of the reciprocal of n, minus 1. So you get this discount rate or the interest rate. Alright, so if you are using formula and you are using the normal calculator, scientific calculator, you need to know how to use these keys. y to the power of x, okay, because this